All right, let's get started then. If you need a calculator, there's a bunch up on the board up there. From what I've experienced in the past, teaching this now 15 years, I don't think this is the toughest unit, but I think kids after they're done think it's the toughest unit. And the reason, one main reason, everything's brand new. You can't rely on anything you learned back in the middle school days and apply it here. Like last unit, you knew the basics of a rotation, translation, dilation. You knew the basics here. But now the vocabulary is all brand new. So I'm just forewarning people, stay on top of this stuff. All right, stay on top of it because the vocabulary is, a lot of this is all brand new. All right, so we're dealing with circles, more than you ever thought you knew about a circle. Today's topic, circumference. Before I even touch on circumference, though, parts of a circle. Parts of a circle. Radius comes from the center to a point on the circle. You double the radius, you get the diameter, which is a segment where the two endpoints are on the circle. Okay? What if it doesn't go through the center, but the endpoints are still on the circle? This may be new, I don't know. We call it a chord. All right? A segment that does not go through the center is called a chord. Can we call a diameter a chord? Are the endpoints on the circle? Yes, it is. And more importantly, and here's what I need you to jot down for me, the diameter is the longest chord in the circle. Okay, it's the longest chord in the circle. Have you been exposed to that word chord before? No? Okay, some of us have, some of us haven't. But do you see the difference? Hey, see the difference between a chord and a radius? Chord, the endpoints are on the circle. Radius, one endpoint is the center. Next thing I'm going to just talk about, how do you name a circle? Like you name a triangle with the 3 vertices. You name a square with the 4 vertices. How do I name a circle? By its center point. Okay, by its center point. So this circle here, I would call circle C. And that tells me C is the center. Or, and I'll allow you to do this, you'll see this from time to time, the symbol for circle is a circle with a center in there. So that could also be circle C. And if you want to jot it down or not, you name a circle by its center. Okay? Yes, Hugh. Sure. All good on different pieces of a circle and how to name it now. We're all good? All right. Can 2 circles be congruent? What do you think? Yes, if anybody, because not all circles are congruent. The radii are the same length. Okay? Only if the radii are the same. And then I say radii, that's the plural for radius. It's not radiuses. All right? So if their radii are congruent. Okay, so if you hear me say radii, that's what I'm talking about. 2 radius. Can circles be similar? Remember what similar meant? Same size, same shape, different size. All circles are similar to each other. All right, does not matter what the radius length is. All circles are similar. Okay, so they're congruent. If the radii are congruent, they're similar always. I think maybe you've heard of this, or you know pictures of them anyway. Concentric circles. Circles that have the same center. Any real life examples here? Circles that have the same center? The O's. Yeah, the O and O's, yep. Donuts. No. Okay. There you go. Bullseyes, yep. Bunch of concent. That's just not two concent. That's a lot of concentric circles in a bullseye. Dartboards, yep, concentric circles. Circles that have the same center. Tires. We could get anybody else want to add on there? What, Emma? Okay, Cheerios. That's good. I like that. Okay. All right, we're good? Before we start listing out all the different types of Cheerios. A clock. There you go. Yep. Nice job. Fruit Loops. Any bootleg kind at Price Chopper, ShopRite, or Hannaford, right? Yep. Yep. All right, moving on. I do like the excitement. Inscribed. A polygon inscribed in the circle. Inscribed sounds like the word inside. We're off to a good start. Inside, meaning the polygon is inside the circle. All right, inside the circle. Circumscribed tells me something is outside. So in this case, it's saying the circle is circumscribed, meaning the circle's on the outside, so I call it circumscribed. Whatever's on the inside, I call inscribed. Could I flip it? Could I put the circle inside? Yeah, then I would say the circle is inscribed, the polygon is circumscribed. Whatever's on the outside, I refer to as circumscribed, inside, inscribed. All right? All right, here's the topic for today. Circumference. It's a fancy way of saying the perimeter of a circle. And perimeter, all sides added up, but there's a problem. Circle does not have sides. All right, so we call it circumference. All right, that's the distance around there. There are two formulas, which I will not going to give to you, that you can use. Pi d or 2 pi r. Why are they the same? Anybody remember how a radius works with the diameter? Diameter equals twice the radius, so that's where that comes from right there. You guys decide what you want to use. I don't care what you use. We'll make class decisions along the way to figure out which one we'll use. If you want a little trick, and this is not coming from me, I've heard this from other people. If you use C equals pi d, coffee pie donuts, if you want to remember that way. Cherry pies are delicious. Well, there's also here's the other area of a circle, which we'll get into next unit, is pi r squared. So the second half of that is cherry pies are delicious, apple pies are too. But whatever goes for you guys, whatever you want to use. That's right, whatever floats your boat. All right, so whatever formula you want to use for circumference, go ahead. All right, here we go. Now I'm going to hear from you guys. Find the circumference of this circle. Leave your answer in terms of pi, which means your answer will have pi in there. Do not hit the pi button on your calculator. All right, leave your answer in terms of pi. That's what it means. All right, so for here, class, do we want pi d or 2 pi r? 2 pi r, fine. Here we go, circumference 2 times pi. What's the radius length in this case? Not too bad, it's a basic one, 16. I am not going to go to my calculator and do 16 times pi times 2. It said leave your answer in terms of pi, which means you should have pi right in your answer. So instead, you're going to multiply 2 times 16. And that just ends up being 32. And we write it with 32 pi, not pi 32. Do you guys write 6x or x6? There you go. Okay, so we'll write 32 pi. And yes, I want units, but this one does not have it, so we'll just leave it in terms of pi, 32 pi. Questions? Okay, before we do this next one, I just got to pull up my calculator. Okay, Find the diameter and radius now. I give you the circumference is 106.4 millimeters. What was the radius and diameter then? I'm actually going to do this using both the formulas, pi d and 2 pi r. I just want to make a point if any of you guys try to use either one. You know the circumference, plug it in. 106.4 equals pi d. How would you go about solving for the diameter here, which is d? What would I have to do on both sides to solve for the diameter? Will? Divide by pi. Pi is just a number, 3.14, da 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 da. So I can divide both sides by pi, yep. D equals, so I go to my calculator, 106.4 divided by pi. If you want to use your fraction template, absolutely. Where's the pi? I can't even see anything here. Sure, go ahead. Pi? Nope. Where's the pi button? Over the caret. Thank you. Can't see anything up here. Okay, so we get rounded. What it's asked, rounded to the nearest hundredth, 33.87. Yep. All right. Make sure we're focused in on this point here. Hold on, I forgot my units. Millimeters. Okay, now it's also asking for the radius. So a lot of us are like, I'll just divide that by 2. Not that one, you're not. Because that's not going to be an exact answer for us. I'm going to go back and divide my original calculator display by 2. Okay, don't divide your rounded answer by 2. So 16.93. Okay, you can just take this. I just want to show you something. Let's say instead of using pi d, you chose to use 2 pi r. Take a peek. What would I have to do on both sides here to get r by itself? Okay, divide by 2 pi. Correct. And all I need you to do is watch me up here. Ready? So I'm going to do 106 point, what was it? 4? Divided by 2 pi. And you guys know what the radius should be already from the first part. Why didn't I get the same thing there? Here's the deal. Yes, Kim, here's the deal. Right now, your calculator is going to do order of operations, which it's going to do 106.4 divided by 2 only. And then it's going to take that answer and multiply by pi, which we don't want. So what's the solution to it? One of 2 ways. Put the 2 pi in parentheses, or heck, hey, how about we actually start using it once in a while? Use your fraction template, 106.4. You don't have to worry about parentheses. 2 pi. There you go. Okay? So everyone all right on that? If you end up dividing by 2 pi, be careful. Either put it in parentheses or your fraction template. Questions before we get tougher now? All right, let's get tougher then. Oh, good. All right, great. Let's go. All right, what's it going to be? First day back. Welcome back. Maybe you might have no homework here. Let's go. Star. Page turn.
What did we get last time?
Page curl was the last time.
Curl.
That's the one where like slide to the top right. Well, wait, what about the one where it's like a box and it comes out?
Cube.
Cube. Yeah, cube.
Okay, here you go. I got cube. I got cube, star, page curl, clock.
I think Will was right the second time.
Okay, star. Do I have any stars? Do I have any page curls? Cubes?
I like cube.
So you're going with clock then, I assume. Clock, all right. Clock or Prometheus. So clock, here you go, clock. Everyone ready? Clock or Promethean man, here we go. So am I. Clock or Promethean man? More suspense, here you go. More suspense. Ooh, sorry, shatter. Okay, ready? Here we go. Let's get back to it. A square with side lengths 9 inches is inscribed. What did we just talk about with inscribed? Where's the square? Inside circle J. J tells me what? If I'm calling it circle J. That's the center J. So let's make a little diagram here. So let's get circle, where the center must be J. And what's inside here? The square. And if the square is inside, that means each of the vertices are touching the circle. So here's my square I'm going to put inside. Not bad. Okay, there it is. And we're supposed to find the exact circumference. Quickly here, exact. No decimals in your answers. Well, we'll talk about it. That just means I can't have 62.85922, whatever's on your calculator. I need some other version of that, which we'll get to. All right, so it's looking for circumference. What formula do we want to try out here? Pi d, 2 pi r. Pi d, perfect. I like using pi d. What's the only value I need to find? I need to find what the heck the diameter is. What's up, Sean? In a second, champ. In the second. Okay. So I need your help finding the diameter, which is not even drawn in yet. All right. Now, I could draw the diameter in a lot of different ways here. Take a look. But only one way is going to be appropriate. I could do the diameter like that. There's the diameter. I don't know how I'm going to find that, though. I could do it also like this. That's a cute diameter right there. All right. That's not going to help me out, though. Is there a diameter, though, that may help me out that I can draw? Sean, go ahead. A diagonal of the square. Can you find that diagonal of the square? If you can, you have found the diameter. And we also know that each side is 9 inches. And it's a square. A lot of different ways you have. Anybody want to take how we're going to find the diameter now that I know that's a square? It's a square. A lot of different ways. Good, Will. Okay, one way is Pythag. Ooh, I'm going to challenge you, Enrich Kids. Any other way? What's this right here? It's a right angle. It's a square. Right? 45, 40. It's a 45, 45, 90 triangle if you remember your rules. I think I'm going to go that way because I know everyone can do Pythag in here. So I'm just going to review that way. So does everybody see that that's 90? These two sides are equal. So what do you know about the angles across? They're equal as well, and they have to be 45 then, if that's the case. All right, real quickly here, let's get out our rules. And you'll see doing it this way is a little bit quicker than Pythag, but anybody remember? Across from the 45s are both the same. They're both x's. And what about the 90? Nice job, Justin. X radical 2. What are across from the 45s? 9 and 9. What's across from the 90, my diagonal? 9 radical 2, which you wouldn't have gotten from Pythag, but if you reduced your answer from Pythag, you would have got 9 radical 2. Because I believe when you do Pythag, you guys would have gotten 162. Square root of 162, which breaks down into 9 radical 2. Okay? All right, so we know the diameter now. 9 radical 2. And remember, exact, no decimals in your answers, so guess what? That's how we're going to leave it. I'm not going to multiply 9 radical 2 times pi on my calculator because that'll give me decimals. So I'm just going to clean it up, very minor cleanup here, just to make sure the pi goes last. And I'm still missing units. What was our units here? Inches. And I know this seems very elementary and petty of me, but make sure that pi is clearly outside your radical. All right, it's not the square root of 2 pi. It's square root of 2 and then pi on the outside. Ask away here, because it's only going to get slightly tougher here. Ask away. Anything there? Again, could you have gotten away with Pythag? Yes, you could have. You would just have to break down that radical that you got. Any issues from you guys? Okay. Center of circle Q is 3, -2. If the circle goes through 7, 1, what's the length of the diameter? So what I did here, I just to give you guys a visual. Here's Q. Here's the point on there. Here's what I'm looking at. Get the old compass out real quick so I don't embarrass myself. Okay, here you go. Here's what we're looking at. Here's the circle. And I'm looking for the length of the diameter. Here's what you know. Center, point on the circle. What's the length of one of the diameters? Go ahead, Emma. Got a plan for me. Will give me what? This distance here is the what? The radius, and how do you know it involves the diameter? Take that distance in, multiply by 2. Everyone see that? Right now, giving you Q and the point on the circle, R. That gives me a radius. I can find that by using what formula? Distance formula, and then multiplying that by 2 to find the diameter. All right, let me just quickly, we've gone using this a ton. It seems like every unit. x2 minus x1 squared plus y2 minus y1 squared. All right, finally hearing from somebody today. Here you go, 14. Want to plug them in for me? Got it. Plus 1 plus 2 squared. Yep, minus and negative gives you a positive 2. All right, let's keep this train rolling here. It looks like I got 4 squared plus 3 squared. It's at the square root of 25. So how long is the radius at least? Radius, 5 units. Meaning the diameter length will be equal to 10. What else could I ask you to find instead of the diameter length? What have we been talking about today? Circumference. Oh, speaking of that, here you go. Two, 212, endpoints of the diameter of a circle. What's the circumference? You and your group. I'll give you 3 or 4 minutes. Go ahead. I gave you the endpoints of the diameter. What's the circumference? So whatever formula you prefer. I'll be interested to see if anybody notices anything in any of the groups. This one? No. Well, you can leave it. Actually, it should, well, your final, the circumference, yes. Let's go nearest hundredth. Okay, we'll go nearest hundredth. Thank you. Hundredth, please. Hundredth, yes.
You need to. That'd be square root. I got that. Nick is like.
Okay, hold on. 17, first thing you did? So I need the diameter. So how'd you find the diameter length? Okay, I don't know. Did anybody else notice that? Not use the distance formula and notice that 2, 2, and 2, 12, they'll have the same x coordinate, so they're right on top of each other. But distance formula, either way, distance formula or noticing that, Max, should have gave you a diameter length of what? 10. So d equals 10 here, no matter how you did it. And we plug it in, you end up with 10 pi, rounded to the nearest hundredth. What do you end up with, Max? 4.2 and no units, so I don't need to put units on mine. All right. Questions from you guys? Okay, take your time right now. You get a lot of it done. And